Hello everyone, my name is Niklas and I work at Moovel, and today I'll be talking about Gradle and how you can go and write your own Gradle plugin. So let's first go and start with the Android Gradle plugin. So everyone who's developing Android is using the Android Gradle plugin to go and do that. So everyone knows that we apply the plugin by saying apply plugin, Android application. If we actually go and have a closer look, we can go and decipher that into a function call. So there's an apply function inside your build.gradle file, and then there's the parameter passed. And if we go and dive deeper into that, it's actually a set. So we pass in a set with the key, which is called plugin, and then the Android application. Also, Gradle needs some kind of way to go and know where this Gradle plugin is coming from. So there we have this build script DSL block where we can go and say which repositories we are having. So for instance, Google, Maven Central. And then also in the dependencies block itself, we can go and say the class path for the Android plugin. So here it's Android tools, Android tools.build. And then when you invoke Gradle, Gradle is downloading that jar file from the Google repository and caching it locally. So all of the Gradle dependencies, they're cached inside the .home directory, inside .gradle. And if we go and have a look at the specific directory here, we can also go and see that the Android tools.build file is there. If we go and dive deeper and also look at the folder there, we can go and see that multiple versions of that Gradle plugin is being stored there. And if we go and also look in the specific folder of the plugin that we applied, we can go and see that there are 3 files. So first of all, there's the POM file. The POM file is first of all saying what is the group ID of the plugin, the artifact ID, and then also all of the dependencies that are being used by the plugin itself. Furthermore, we also have access to the source file of the Gradle plugin, and then there's also the compiled jar, which is being used by Gradle to go and invoke the plugin. We can easily go and unzip that jar file, which contains the sources, and if we do that, we can go and see that there's a meta-inf directory, which has the Gradle plugins directory. And if we remember when we were applying the plugin, we were saying Android application, and now we can go and relate that there's a Android application properties file, and then if we're going to go and have a look at that, and then also there's the Android build Gradle directories where all of the class files are being stored, or in this case where we are looking at the sources jar, all of the source code. So remember when we're applying the plugin, we say apply plugin, Android application, and then Gradle internally is looking at all of the dependencies that we added as a class path inside that build script, and then it's basically looking at those properties files and it's trying to go and find the proper plugin. If we go and have a look at the properties file, we can go and see that there's an implementation class and then the fully qualified name. So Gradle can go and use that, instantiate that class, and then if we look at the source file of that particular class, it's nothing interesting there. The plugin is extending from an abstract app plugin. Since we have the source code, we can also go and look at the abstract app plugin. That one is extending from the base plugin. And then finally, in the base plugin, we can see where the Gradle API is being used. So if you want to go and write a custom plugin, you need to go and implement the plugin interface. And then there's a generic, which is the project, and then you have to override one method. So if we go back again where we're applying our project, we say apply plugin, Android application, then Gradle is looking for that particular fully qualified name of the class that it can go instantiate with the respective name, and then it will go and call that apply function. And in that apply function, you go and get a parameter, which is the project. The project type itself is also coming from the Gradle API, and there you can go and get certain information like which other kind of plugins are applied, what is the name of the project, where the project is located. Now that we have all of this information, we can go and start writing our own custom plugin. So first of all, we're going to be writing it in Kotlin, so we are going to go create a new module. With that module, we're going to apply the Gradle plugin, and then as a dependency, we will be using the Gradle API. So once we have that, we can also go and create our own new custom file, the sample plugin. We're implementing that interface from Gradle, the plugin, and then in that apply function, we're just going to be saying for now, hello droidCon Berlin. So this is everything for our plugin itself, and now if we want to go and imagine that, we have this little box. But somehow we need to go and provide that plugin, because others, they should be using it. So providing the plugin, remember in the previous case with the Android Gradle plugin, there was this properties file. So somehow we also need to have that properties files inside our jar, where we go and say the implementation class is the fully qualified name for the plugin that we just created. Gradle itself is coming with a Java Gradle plugin, which we can go and use to go and do the job for us. So we can configure the Gradle plugin. We can have a list of plugins that we're supporting out of this repository. In this case, we only have one. We give it an ID. This is also the ID that will be used in the apply plugin, and then the implementation class. So for the implementation class, we pass in the fully qualified name. And once we do that, and we go and assemble our project, so we can use Gradle assemble. And then in our build libs directory, there's going to be the fully compiled jar. We can also unzip that again. And then once we do that, we can see that the sample plugin class has been compiled from a Kotlin file to a class file, and also that meta-inf directory has been created. So, and with that meta-inf directory being created, it also contains the proper property file, and by using that, it can go and then reference the plugin again. So now we have everything in place, and we could be using that jar. Now, we optionally, or like best case scenario, we also go and publish our Gradle plugin. So everyone is using the Android Gradle plugin. There are also other plugins like SQL Delight or the Butterknife Gradle plugin. And usually they're being published to Maven Central. But what we can also go and do is we can publish them to our local Maven directory. So every computer has a directory inside the home directory where we can also go and publish jar files. I wrote a script for that, which can go and publish it. It's based on the Chris Baines publish.gradle script that is out there in the wild and everyone is using. So in order to go and publish our own Gradle plugin that we just written, we can go and apply another plugin, which is the Maven Publish plugin. And then we only need to set a few more properties. So we need the group identifier, the POM artifact ID, and the version name. And if you remember, this is the information that you put inside the build script. And then we also say that it's a jar file, the packaging. So inside our project where we're creating our own Gradle plugin, we can go and say install archives, which goes and builds the plugin itself as a jar file, and then places it inside the local Maven repository. And the local Maven repository is inside the home directory under the m2.m2 directory, and then /repository. And then here you can already go and see the group ID and the artifact ID. And then if we ls into that, we can go and see the version name. We have given it the o.1.snapshot. And then also here we can go and see that there's the jar file, which we go and need, the POM file, and in this scenario we also have published the sources. So next up we can go to the project where we want to go and use that Gradle plugin, and we can start consuming that plugin. And for that we only need to do 3 lines. So we say in the repositories block, we also want to go and get dependencies from Maven local. For the class path, we can go and give in that name that we've just given to the Gradle plugin, and then we can apply the plugin. And now this is a bit of a hassle, and this is something that's a bit tedious, but that only needs to be done once. And once that has been done, we can go and make changes to our Gradle plugin. We have a project where we can go and try it out. So let's go and do that. So in our project, we can go and run Gradle W, which invokes Gradle. And then during the configuration phase, our plugin is applied, and then we go and see our hello droidCon Berlin. So this is the first success moment. If we go and look at the graph again, we can go and see that there's the Gradle project now, which is consuming our plugin. And now you might be asking, now we're done, right? But essentially, the plugin is not doing a lot of work. Currently, it's just printing out a line. And the type of work that you want to do really depends on your use case. So you can go and write something to go and, for instance, collect stats on your project, or you can go and make an integration to like a third-party service. And now we're going to go and dive deeper into the extensions and also all of kind of APIs that Gradle is providing, so we can go and leverage all of the API that they've built. So the first one that we're going to be covering is extensions. And the Gradle extension is something that everyone is using. So in our case, we already used this when we applied the Java Gradle plugin, and then we configured the extension, which is called Gradle plugin, to go and list also our repository. Another common use case is the Android block that we're using to go and configure the compile SDK version, the min SDK version, all of the lint options, basically everything. And this is also an extension. Now, if we were to go and also write our own extension, we just need to simply go and create a new class. It is open because Gradle is doing some reflection at runtime for that, and it needs to be able to go and modify it. And we also have a new property, which is called name, and it's of an optional type of a string. Next, in our sample plugin, that's the same file as we had earlier. If we apply the plugin, we can use the project type from Gradle to go onto extensions, and there we can go and create our own extension. The first parameter is the sample plugin. This is the DSL kind of block that you go and configure it with. So in case of Android, it's Android there, and then we just pass in the class file for our extension that we created. Next, we can go and get the name, and then we can go and print it out. Now we go and apply the plugin again in our sample project. We can configure it using the sample plugin DSL. We can give it a name, and then we run it, and it says hello droidCon Berlin, which might be a bit confusing. The reason behind this is, though, the apply function is called the moment the plugin is applied, which is the first line. So we haven't, or the plugin hasn't seen that the DSL for the extension has been configured yet. So it will go and take the default value. To go and work around that, or let's say there's a different way how we can go and provide feature flags or like properties at the configuration phase. So the configuration phase is when Gradle is applying the plugin, and there we can use properties. And also the properties we've also already used. So the first time that we used it was when we were setting the group and the POM artifact ID and the version name. And more commonly known, it's the flag that also you can go and provide to the Android Gradle plugin. So if you're using Android X, you have the android.use androidx equals true inside your Gradle.properties files, and there are also a bunch of more options. Also, that way you can go and configure the Gradle daemon, or whether you want to go and have incremental CAPT, so Kotlin annotation processing. And if we, inside our plugin, we want to go and access that, we can use the project, and then it has a properties map. And in that property maps, we can go and get the name, and then we can go and print it out. So if we go and say that the name equals world in our Gradle.properties files, and we run Gradle, it also says hello world. Looking back at the graph, we have now our Gradle project. We apply our sample plugin, and then the sample plugin is also providing an extension that can be configured, and the Gradle project is also setting that. Now, usually you don't want to do anything when your plugin is applied, because every time you invoke Gradle, all of the plugins are being applied for you. So let's say you're running a Gradle task, which is help, or task, or a sample debug, the plugin is applied. So in that apply function, you really want to do as little as possible, and then you only want to do work when there's something that needs to be done. And that's the main feature that also Gradle is providing, which is called a task. So a task is something where you can say, for instance, a sample debug, which is essentially building your Android application and then providing you that APK. So if we want to go and create our own task, we go back into our sample plugin file. Also there we have the apply function, and then we can go and create a new class, which is called the greetme task. That one is extending from a default task, and then we can go and give it a property which we can go and configure. And then there's this main function which is called run. That one we annotate with task action, which is something from the Gradle API, and that way Gradle knows which function to go invoke when we go and call that task. The only thing missing now is to go and register that task. So under project type, we also have a task class where we can go and register task. In this case, we're saying the task is called greetme. We go and pass in the class file, and then the last closure, the parameter, we can go and configure it. So when we call greetme, the task is being created. Since we are registering it, we're not actually creating it, so everything is being done lazily. And then once that task is being called, we can configure it, and this time we can go and get the extension name. And now if we go back to our previous sample code that we used, and where we also configured the name, this time if we're executing the task, it will also go and print out hello foo. because Gradle has 3 different phases. It has the initialization phase, which is where Gradle is creating all of the projects, which are being listed in settings.gradle. Then it has the configuration phase, where all of the plugins are applied, and then the execution phase. And the execution phase is when a task is being run. And this time it's the create.me task, which is being run. It can go and get to the extension, it can go and read it, and it will go and print it out. So looking back at the graph, we also have this create.me task, but only having one plugin is kind of boring, so we also go and apply the Android plugin. The Android plugin is also doing its own extensions, and it's providing a bunch of tasks. And if you have a lot of plugins, or let's say a lot of modules, and the number of tasks, they can go and increase. So the Android plugin is probably going bringing like 500 tasks for each module. Let's say you have 20 modules, and if all of those tasks are being created every time you go and invoke Gradle, this is already going to go and cost you a lot of build time. So, which is why previously, I think a few months ago, Gradle announced the task configuration avoidance. And previously, you were creating tasks actively. So you were saying project.task.create, and then you were giving the name. And then we could also say, for instance, if we go and execute that task, we want to be depending on another task. In this case, it's the assemble debug. So that way you can actually go and have this chain. Because when you execute assemble debug, this is not the only task that is running. It's actually running a lot of things before. So it's packaging the resources, it's assembling the resources, it's invoking AAPT2, and also compiling your Java files, compiling your Kotlin files before that annotation processing might happen. And then instead of using the create function, we can go and use the register function, which will go and lazily, only when that task is being invoked, go and create it. That way, the entire dependency graph of all of the tasks, they don't need to be calculated upfront, so it can all be done lazily. So in this case, we register our new task. We can also say that it depends on the assemble debug task. And then in our graph, again, it looks like this. So our create.me task is depending on assemble debug. And one common use case or one common scenario where this is being used is the Fabric plugin. So we can also go and apply the Fabric plugin. It's bringing its own extension again. And the Fabric plugin has the Crashlytics upload distribution debug task, which is uploading the APK to Fabric, to the beta program where you can go and download it. And then that task can go and say, okay, I need an APK to download. I know that the Android plugin is applied, and then I can go and invoke that task, get the outputs, which is the APK, use the path, and upload it to the Fabric server. And this can go all sorts of ways. So our create.me task can also go and read the Android extension properties. It can go and depend on another task. So it's really up to you. The most important point is that you're being careful, though, and that you're not depending on too many things, because you don't want to be doing work that doesn't need to be done, because in the end result, you're wasting build time. Another part to go and increase the build time is by using incremental build and task. So let's go back to our create.me task. We can say Gradle w create.me. It's going to execute it, and then we can go and execute it again, but nothing has changed. And ideally, we wouldn't be printing out and creating you again. While this is a simple scenario, let's say you're changing your resources file in one of your Android projects. You don't want to be recompiling all of your Java code again if the only thing you changed was a text color. So by splitting up each work into a separate task, you can go and define inputs and outputs. So if we go, ideally, if we go and run the task again, create.me, it says up to date. And in order to go and have this functionality, we need to go and apply inputs and outputs. So this is the sample plugin that we were using before. And in order to go and make it incremental, we only need to do those 2 changes. So the first one that we did was we defined an input annotation on the name to create. This is an annotation that's provided by Gradle. And then Gradle will go and basically build like a incremental compilation to go and see, has that name been changed, has it not? And then also the second part of the API which is required is outputs. So inputs, they need tasks, they need inputs and outputs. And if the inputs and outputs are the same, Gradle knows that the task doesn't need to be running. So in this case, since our task is not outputting really anything, we can just say task outputs up to date when, and then we say true. We can also go and change it to go and print to a file though. So we go and add a second property, which is called output file of type file. And then also Gradle is providing an output file annotation that can be used. And then in our closure, where we can go and configure the task, we can go and say the output file is going to be in the build directory with the name greeting.txt. And this is everything that needs to be done, and Gradle will do all the rest of it. So if we go back again, we say greet me, our build is successful, one is executed. We can go and cut and see that it has been printed out into the file. And then if we go and run the task again, it's up to date. And then now time is being spent, and everyone is happy because your build is not taking too long. We can go and take this even further by leveraging the build cache. So build cache is, there are two different types of build cache. There's one where you can use on your local machine, where the outputs are being stored on the local machine, and then you can also go and use a remote build cache. So for instance, you can go and set up a server. You can, Gradle is providing a Docker image which you can go and use. You can spin it up, and then all of the outputs are being cached on that server, and then locally you can go and get the outputs. So the big benefit is that if, for instance, one of your colleagues is running a Gradle build, the outputs are being stored, and then if you were to go and run the same build with the same parameters and everything, you could go and get the build cache, and you wouldn't need to go and compute everything again. So let's go and see how that looks like. So we go and execute our task again, which is called greet me. Then we can do a Gradle clean. But then this time, if we were to go and greet us again without changing everything, the task would be executed. Ideally, it would be saying that the task has been executed from cache, so one from cache. And also doing this inside the Gradle plugin is super easy. So we have our task, which is the greet me task, and then we can also slam two more annotations on it. The first one is saying that this task can be cacheable by saying it's a cacheable task, and the second one is a path sensitive. So the reason for the path sensitive is that on your local machine, you're going to go and have a different path than on the CI machine, because your username is different. You might be having a local MacBook, and then your CI is a Linux server, and the path files itself, they're going to be different. In order to not go and lose the build cache feature, you can go and say which sensitivity it should go and have. So whether it's an absolute path, relative, whether it's important or not. Now, let's go and look how we can go and test all of this. So also your Gradle plugin, you can go and, as I already said and mentioned, do everything you want. And usually the Gradle plugins, they don't contain a lot of logic. Rather, they're deferring the work to like a jar file. So in the case of Android, D8 and R8 is being used to go on DEX and also shrink your application. But not the actual code for shrinking and DEXing is inside the plugin. So instead, they're building those features, they're packing them as jar, and then you can add them as a dependency to the Gradle plugin. So in your Gradle plugin, you can also go and use RxJava, Retrofit, all of the good libraries, and you can go and leverage everything. And then the tasks are essentially only like clues. So you clue your the invocation of the work that you want to do to your business logic. So I would advise everything that's easily testable from within JUnit. You can go and test, and then for actually testing the Gradle invocations, you can go and use the Gradle test kit runner. So we can also go and do that. We'll create a new test file, and then we also use the JUnit temporary folder rule. So we will be creating a new folder, and then also a new build.gradle file. So we can write to a new file, and then we can use the new plugin syntax to go and apply our plugin. And then we can use the Gradle runner to go and use the test infrastructure. So the first method that we're going to be calling is with plugin class path, which is essentially a way that we can go and access our plugin, because we're still in the same source directory, and we don't have any reference yet. But since we also earlier applied the Java Gradle plugin, this one is essentially assembling the jar file, putting it into a directory, and then that with plugin class path can go and retrieve that jar file, and then we can go and get a valid reference to our project. Then for the project here, we can go and say that's the root directory of the temporary folder that we created for the test. With arguments, we can go and say which kind of task we want to execute, and then we say build. Build is returning a build result, which we can go and query. So we can see for the task readme that the outcome is success. And furthermore, we can also go and assert that the content has been written properly to the file. So we can go and from the temporary folder, we can go to the build/creating.txt file. We can also read the text and assert that the plugin has been writing the text correctly to the file. Another use case or another test scenario which we might go and have is by using the DSL to go and configure it. So we apply the plugin, then we also say sample plugin name equals world, and then the invocation is essentially the same. And then this time we can go and assert that the name that we want to go and create with is going to be used to go and store in the creating.txt file. Those are like the rather easy scenarios, so you can go and see that your Gradle task is behaving the way you want to, that it's first of all succeeding, which is important because you don't want to have flaky Gradle tasks, and then also that it's doing the job that it should. Furthermore, you can also go and assert that the incremental compilation that I talked about earlier when defining your inputs and outputs is also being working correctly. So we can go invoke it once. This time the task outcome is success. And if we invoke it again, we can go and say, okay, this time nothing has changed, so the task should be up to date. Furthermore, in order to go and get the maximum performance, you can also go and use the -- profile on the terminal. This one is a bit limited. It's an HTML view. So you have 5 different categories, so summary, configuration, dependency resolution, artifact transforms, and task execution. In the summary, you go and get some kind of information, how long it took everything. Configuration phase is rather interesting to see how long it took your project to go and configure. And this ideally shouldn't be longer than 1 second per module that you have. Dependency resolution is to go and resolve all of the dependencies that you have. This one is not important because our plugin isn't using any dependencies and adding them. So one use case, for instance, or one plugin that is doing that is the Android lint plugin. So Android lint plugin, when you use that, it's also adding the lint checks as a dependency, and then it needs to go and do dependency resolution. Artifact transforms I'm going to be skipping, but one use case for that is Chatifier, where the old support libraries are being chatified. And then for task execution, you can go and have a look, and then there you see most of the tasks are up to date. But for instance, the merge debug Java resource, the merge debug assets task isn't up to date. So this profile report I ran on a project which was using the Firebase plugin, and the Firebase plugin version 4.2 isn't incremental, so it's creating the same resource file for you from that JSON file every time. And as you can see, if one of the tasks isn't incremental, all of the tasks that are depending on it aren't incremental either. So they're all being run. And I believe now in the 4.3 version of the Firebase Gradle plugin, they finally fixed it. Now, if you want to go and dive deeper into the performance, you can go and use the -- scan flag. And then you get an HTML report which looks like this, and it's also been advertised many times already on this conference. But you can go and get, for instance, a nice overview of some of the deprecated function or method calls that some of your plugins might be using. You get an overview of which task took the longest, how many tasks are being run. And then we can also look into the performance. So we can go and see how long it took to go and run everything. We can go and also look at the initialization and configuration phase. So that shouldn't be too high. This is actually way too high with 40 seconds. But yeah, I should go and look at the project and see what's taking so long. And then also the execution phase. And yeah, it's just a nice overview. And then we can also go and look at the Gradle task. So we can go and sort by longest. And then we can clearly see that Kotlin annotation processing is taking the longest. And ideally, if you're writing a Gradle plugin, your task shouldn't be up there. So you can go and look at your Gradle task. You can see how long it takes to go and run. And you can go and see and deep dive. You can click on each task, and you can see what exactly is taking that long. The scan feature also has a nice quick tips section, I think it's called. And there you can also see that this Gradle scan I ran with an outdated version of Gradle. And also some of the task outputs aren't cacheable. And if we go and click onto one of those items, we can also go and query and see which tasks are being ran, which aren't using the build cache feature. And also, you can go and query for everything, so you can see where inputs have been changed and maybe they shouldn't have, or where outputs were not there and they should be. And you can really have a closer look at all of your build pipeline, all of your tasks, and see what is taking the longest. There might be some plugin which is doing something that's not incremental, so it could be just as simple as creating a resource file every time, even though if the inputs and the content of that file hasn't been changed. So let's go and sum it up. The first thing that you need to go and do is you need to create your plugin by implementing the plugin interface, overriding that apply function, and then doing your work that you want to go and do there. Next up, you publish your plugin. You can either go and manually build it and include that jar file. You can also publish it to your local Maven directory, or you can also go one step further and publish it to Maven Central. Next up, you can go and consume your plugin by using the apply plugin syntax and then giving in the name of your plugin. Next, you want to go register your tasks to leverage task configuration avoidance so that the tasks are not being created at configuration time, so they're only being created when you're running them. Make your Gradle tasks incremental. All of your consumers of your Gradle plugin are going to be thankful. Also, make them cacheable so they can go and use build cache, which can go and save a lot of build time. And then test your Gradle plugin, most importantly. So by using the Gradle test kit, also running it on your project, and then just, if there's a regression, write a test for it, fix it, and then you're fine for the future. And then most additionally, also go and profile your Gradle plugin if you're doing a lot of work, and you can either use the -- profile or -- scan parameter for that. And that's all I've got for today. Thank you.